welcome back to I think this is up to part 3 now, so we're looking at this one. So this is a typical Pearson question. This is going to be something that you're going to need to be able to get on top of. So straight away we noticed, because there's two functions, x is being squared and added, but it's also having the square root. So the two function idea applies in this case. So it's very important that you follow procedure and build up your chain rule. Okay. Alright, so find the gradient when x equals 2. So the first thing is to find the gradient, mt. So let's go about setting let u equal x squared plus 12. Then let us reassign y, and the square root of something is to the power of a half. So I'm going to start to do that a bit more often now. Okay, so that you can see that that's all like what's going to happen in Math 1. Alright, so we want to find the dy dx, this particular function, and dy dx is going to be done through the chain rule. We're still going to have dy dx, there it is, but we're going to go through something else. We're still going to have dy dx. Let's see what we're going to go through, maybe du. So this one here is Leibniz notation. Okay, and the same here with respect to x. So we've got y with respect to u, and u with respect to x. So then we go ahead and do the calculus. So let's do the calculus. 1, 2, 3, done. Over here, let's do the calculus. 1, 2, 3, 4. The calculus has been done. Okay, so let's go over here and hive off this half minus 1, which I know some of you will say, come on, really? But you know me, I'm constantly encouraging you to get that right. So that'll be 1 half u to the negative half, which is now going to be taken underneath as 1 to u to the half, and the final step is 1 through to u, and we can put the u back in. That'll be 1 over 2 root x squared plus 12. We put that there. X squared plus 12 multiplied by 2x. And the 2x will sit on top. The 2 root x squared plus 12. Now you'll notice they'll cancel. And so we're left with dy dx of x over the square root of x squared plus 12. So that's our dy dx. That's our y dash. That's our gradient. And it's the gradient of our tangent. We're always finding the gradient of the tangent. Okay, so what we want to do here then is consider the gradient at 2. So we've only done that bit of A. And so the second bit is to use function notation, any one of those, at 2, or y dash at 2, mt, it'll all be the same. They'll all mean the same thing. We can even put f dash. You can say the tangent is equal to f dash of xo. And xo would be this one, wouldn't it? So this thing's got a curve on it, which we're familiar with. Then there's a tangent that races off. It has a y equals mx plus b. And we just found that one. and in particular we're being asked for it at a particular location. So let's find out what the location is. So 2, so we're going to have 2 over the square root of 2 squared plus 12. 2 squared is 4. 4 plus 12 is 16. It's 2 over 4, which is a half. So it's a very lazy old gradient, half. Okay. So the other thing we want to find out is the y value. What's the y value here? Because we're asked to find the equation of the tangent. So we really should put 2 into this one. So using function notation, 2 square root of 2 squared plus 12 is 4 plus 12, which is 16, which is 4. So we've got a pair. We've got the M pair of x is 2 and y is 4. That's the xy pair, where x was 2 and y is 4. So we found out the values. So there's a couple of substitutions in there. So the yt will be mx plus b. M we found out as a half. xo, if you want to, plus b. Now we have both of those, x and y, as 2 and 4, so we just substitute those in. 4 is equal to 1/2 of 2 plus b. So that's 2 over 2, which is 1 plus b. So subtract 1. B is equal to 3. B is equal to 3. So the equation of the tangent is equal to 1/2 x plus 3. That is your tangent. Now you will need to do that in Pearson. It's a lot of work, but the calculus is not the problem. The calculus is not the problem. Alright, so to repeat that for part B, so there's our part B, and for part C, what's the normal? So the normal is the part where it's coming up as a curve at a point, and you have your tangent shooting off like that. The normal will be at right angles. Okay, so this has got a yt half x plus 3. This has got a what? Y normal equals, and we've got to fill that in. Okay, so one of the ways that we do that is we recognise that a tangent product with a normal is equal to -1. Rearranging, because we have mt as a half, so we can then clear the fractions with times both sides by 2. So the normal gradient is -2. Now we've got the normal gradient, we're also aware that it's happening at the same place. So to find out what our equation will be, we'll put in y normal is equal to -2 xo plus b, and using our points, again, 4 equals -2 times 2 plus b, so that's what, -4. So add it to both sides and you'll get b is equal to 8. So yn is -2x plus 8. And that is a typical prerequisite knowledge for going into Maths 1. Okay, being able to identify the curves is something that you'll be required, that it'll be assumed that you know how to do that. Okay, so this is an emphasis. It uses the chain rule. So this is a skill that's needed. Everything on this page, I'm just going to do this, is a big deal for us here today. Okay, so for this week, it's a big deal. Alright, so as we move forward, we can see that we've got some higher derivatives, and it just means that you keep going. The nomenclature, just look at the way they're written. Double dash. Okay, so we just keep going with the requirements. So y dash is simply 2 comes out the front, minus 5. So the order of power reduces by 1. So we've no longer got a square term. The double dash means that we just do it to this one. 2x is going to be 2. Okay, so that's all it is. And everything after this, so y3 and onwards, can you have a 3? Yep, it's going to be 0. Okay. All right, so the next one. So we're going to do a bit of pre-work, some algebraic gymnastics. Y is equal to x to the minus 1. Excuse me. So y dash will be equal to minus 1 will come out the front. Minus 1 is minus 2, which is minus 1 over x squared. So that's the indices rules. Okay. Second double dash. Minus 2 comes out the front. Minus 2 times minus 1 is plus 2. X minus 2 minus 3. So we end up with 2 this time over x cubed. Okay. Now we could keep going like this. This particular one has a pattern. Y3 minus 3 times 2 is minus 6. Minus 3 minus 1 is minus 4. So it'll be minus 6 over x to the 4. Can you notice a pattern? X squared, x cubed. So this goes on. This goes on ad nauseum. And so what we can do is recognize that this has a particular event. So when we talk about this, we're really talking about the order of the differential. So sum n, this was 3, this was 2, this was 1, sum n. So order of differential, we need to be careful of this. This is just a nice piece of information, really. Is going to be minus 1 to the n factorial over x to the n plus 1. So you can plug that in for any n, and you should get the same result. I'll let you do that. Okay, if you haven't seen n factorial before, n factorial is simply 1 times 2 times 3 times n. So for example, 4 factorial would be equal to 1 times 2 times 3 times 4. 4 3s are 12, 24. 8 factorial, so on and so forth. There's a little bit of work that you'll do with factorials in Maths 1, but it's a bit of fun. All right. So we go on to some practices, and the practices are just designed to let you work these out. So you can use technology, or you can just do it yourself. Okay, so where it's fairly straightforward, it's pretty easy to do. So y dash is equal to 6x5. You can check all of these with technology. Y dash is equal to minus our 612, so 72. 11. So you can use technology if you need to. So that helps. Doesn't mean that you're doing anything wrong. It just means that you're wanting to understand how it works. That's all that really is. Okay. So we're going to do minus y equals minus 6x to the power 12. I think that's what it was. Okay. So it's differentiating that term. Differentiate y equals minus 6x minus 72x 11. So it's really quite straightforward. There's another way to present Wolfram, but for this time that'll be enough. So you can go through and you're encouraged to do that. Just focus on what's a constant and what's an x, so sometimes the constant will remain. If there's any pre-work to be done, maybe bringing that one up. Okay, maybe bringing that one up. We've got pi's. There's pre-work there. So there's little things that we can do. Okay, so let's do C. Y dash would be equal to 3 minus 3x squared plus 7 pi x to the 6. This is going to have some pre-work done to it. So pre-work will be P as a function of R, 25R cubed minus 38R to the minus 5, bring that up, plus R to the power of half. So then each of these terms has to be worked out for P dash. So 325 to 75, R squared, minus 5 comes out the front, minus times a minus is a plus, 5/38 are 190, minus 5 minus 1 is minus 6. So just be careful, and this one will be the same, half R, half minus 1. So hopefully what you can see is that the actual calculus is not the problem. Okay, it's not the problem. So a bit of pre-work here for this one, and of course we'll have s is a function of t minus 6t to the minus 6. So s dash will be minus times a minus, which is a plus 36t minus 6 minus 1 is minus 7. So really you've got to go through and do all of these. Okay. So f, is there anything we need to do there? Not really. Theta, pi squared is going to stay the same. Theta dash, that's a bit bizarre, isn't it? So the pi is going to come out the front. We've already got a pi squared, so it'll be pi times pi squared, r to the power pi minus 1 over 3, which will be pi cubed, r to the pi minus 1 over 3. So you can put them all in and check them. Okay, it's not terribly difficult. There's a pre-work for this one. So y is equal to 12e, which is a number, 7x3 plus 2/3 x, and it's like square root of x cubed, so it's 3 over 2 as a fraction. So the pre-work was more difficult. This is a number. Whenever you differentiate a constant, it'll disappear. So y dash will be equal to, gone. 3 times minus 7 is minus 21, x squared. And look at this, cheeky. We've got 3 on 2 times 2 on 3, x to the 3 on 2 minus 1. Huh. Cheeky. Okay, so minus 21x squared, and 3 on 2 is 1.5, so we're left with plus the square root of x. Very straightforward, I think. So for h, I'll just bring those up here. H, we'll have no pre-work. Pre-work y is equal to minus 3x plus 7x5 minus 7x minus 5. So it's just showing you how to do it all. So minus 3x will be minus 3 because the 1 comes out, it becomes a 0. X to the power 0 is 1. 35x4 minus times a minus is a plus. 7 5s are 35. And 35x minus 6, be careful. Minus 5 minus 1. Calculus really isn't the problem. It's the use of indices. 4x to the 0.7 plus 0.2x to the 0.3 minus x to the pi. Just write them out if you need to. use a bit of space, it doesn't matter. 0.7 times 4x, 0.7 minus 1, plus 0.3 times 0.2, x to the power 0.3 minus 1, and that's minus pi x, pi minus 1. So we get 7 fourths 28, 2.8x, 0.7 minus is negative 0.3. 0.3 times 0.2 is 0.6. But now that's an issue because that's really 20% of 3, which is not 0.6, it's 0.06. So sometimes you've got to check your calculations and how you think. You can say that's either 30% of 0.2 or 20% of 0.3. But before you jump to your conclusion, do the scholarly thing and check it. There you go, see? So it's got to be smaller than 0.6, it's got to be 0.06. So that's a positive 0.06. 0.3 minus 1 is minus 0.7. And here we've got minus pi x, pi to the minus 1. Okay, I'll come back for another video because we're at that 20-minute mark. Back soon. Thanks.